So, what we're moving into in 9A is we're still looking at continuous random variables, but we're going to look at further applications of them. So, with 9A, we have here what's called a sampling distribution. And this is what arises when we add observations together. So, we've got, for example, the weight of a carton of eggs can be found by adding the weight of each individual egg together. The length of time of a Netflix binge can be found by adding the length of each episode together. So we have this formula here. Sn is a new variable. Is going to be the sum of observation 1 plus observation 2 all the way up to observation n. Okay, so that's Sn, and the mean of this variable will be equal to n times the mean of x. So I should write the mean of Sn, and the standard deviation of Sn is equal to the standard deviation of x times the square root of n. So both those formulas stated there. Okay, so we have a discrete random variable which has this probability distribution. So we have two events here, 1 and 2. X and the probability of those events occurring. Okay, part A says find the mean and standard deviation of x, and the probabilities we're given are 0.2 and 0.8. Alright, so taking you back to chapter 7, if we're going to calculate the mean of this distribution, we're going to do the event multiplied by the probability plus this event multiplied by the probability. So for part A, we're going to calculate the mean of x. It's equal to 1 times 0.2 plus 2 times 0.8. 0.2 plus 1.6 is 1.8. And for the standard deviation, so we've got a standard deviation formula in here. I don't remember it. So 7D CD. Okay. So there's two ways we can represent the standard deviation, but here's one. The sum of xi, take the mean squared, multiplied by the probability. Square root. So we need our calculators to evaluate it, but what it will look like in this circumstance is, so the first event, 1, take away the mean, and we 1, take the mean, squared, and multiplied by the probability of that event. Plus 2, take the mean, squared, and multiplied by the probability of that event. And square root of the whole thing. That's going to give us the standard deviation of the variable x. So all of this for part A is just a recap of what we've done in chapter 7. And we can do that just on our just in our statistics mode anyway, can't we? So I'll probably do that. It would be easier to type in. Alright, standard deviation is 0.4. Okay, so that's part A. Alright, part B says state the meaning of S10. Okay, so S10 is the variable that occurs by adding 10 observations of x together. Alright. Find the mean and standard deviation of S10. Okay, so the mean of Sn is n times the mean of x. So that means the mean of S10 is going to be 10 times the mean of x. So 10 times 1.8 gives us 18. Alright, standard deviation of S10 is standard deviation of x times the square root of 10. So 0.4 times the square root of 10. And we can leave it like that or evaluate it to a few figures. Okay. And then for part D, state the possible values of S2. So this is one that just requires a little bit of concentration. We can think of this here as like a spinner, right? There's two events. You either get a 1 or you get a 2. Now, if we're going to perform this experiment twice, okay? The first time, the lowest value we could get would be a 1. And then if we repeat it again, the lowest value we could get would also be a 1, which means the lowest value that S2 could take would be 1 plus 1, which is 2. The highest value it can take is if we got a 2 and then a 2, so you could get a 4, but there's also the probability of it getting a 3, right? Where we get a 1 and a 2, or then the 2 and a 1. All right, so that's the sample space of the variable S2. Yeah. Cool. So that's exercise 9A. Let's get into it.